Hey everyone, I am just doing a little video here to help out with the applications part of day 2 of our new topic, which is exponents and radicals. So these are called the application portion because we're taking the skills that we've learned so far and applying them into a different scenario. And this is geometry related. So we want to find the perimeter and area of the following shapes. And so these are similar, not exactly the same as yours, but you can use them to help you. So the thing is, you actually need to know what area and perimeter are. So this is a rectangle. Perimeter is equal to 2 length plus 2 width. You also might use the words base times height, and that's okay too. And what we're going to do is bring these in over here and plug them in for length and width. It doesn't matter which one I use. I'm going to make this one my length. So 2 parentheses 5a squared b squared, oops, 5b to the 4th, plus 2, and then my w is going to be this guy here, 3ab squared. Awesome. So notice there's addition and multiplication happening. So I'm going to look at this first because in PEMDAS you multiply before you add or subtract. And so the only thing I can actually do here is multiply the 2 and the 5. So 5 is 10, and then I just bring everything else down. A squared b to the 4th plus, and then the same thing here. I can only multiply the 2 and the 3, which is 6, and then a b squared. Okay, now if I add these together, I need them to be like terms, which means the exact same variables with the raised to the exact same exponents. So here I have a and b and a and b. This is a squared, and this is just a, and this is b to the 4th, and this is just b, which means I actually cannot combine those. So as weird as it is, this is perimeter. So that might be a little thing that's difficult because it's not like the perimeter is 104. It's using what they give you. So you need to first know the formula, then plug in these weird things they give you, and then use the skills or rules that you learned to then compute it. Okay, and then for area is length times width, or base times height. Again, that's fine. And in this case, again, I made this length, so that's 5a squared b to the 4th, and then 3ab squared. Okay, and what I'm going to do is I'm going to add here that this a has a little 1 there, even though it doesn't have it explicitly. That's what it implies, right? And then a is equal to, and then we only can multiply the things that are have the same basis, right? So we have 5 and 3, and that multiplies to 15. Okay, and we have a squared and a to the 1st. Well, the rule that you learned was when you multiply with the same base, you add the exponent. So 2 plus 1 is 3, so a cubed. And then I lastly do the b's. This is b to the 4th, b squared, and that's b. 4 plus 2 is 6. And there's no units. I'm not going to worry about units. The important part is actually doing the computation part because that's what we learned. So there's the perimeter and the area for the rectangle. So you'll want to use these same formulas for when you go and do the problems on day 2. Now here I have a right triangle. So a right triangle, again, the perimeter you will often find for triangles, we call the sides A, B, and C. Just a thing we do. So I'm just going to call this A, this B, and this C. It doesn't really matter, but you add them all together. So the perimeter is equal to A is 4m squared plus B is 3mn squared, and then C is 7n squared. So again, we can only combine things that are like terms. So this just has an m, but these have m's and n's. So this one's not a like term. I can't do anything with it. But here, this and this are the exact same variables with the exact same exponents. We have m, then n squared, m, and then n squared. So when we bring them together, again, this I is solo, unfortunately, stage is 4m squared. There's nothing to combine them with. And then here I have 3m squared and 7m squared. That makes 7 plus 3 is 10. M squared. Remember, when you combine them, you're only adding the coefficients and the variable part stays exactly the same. So again, there's the perimeter, not answers that we're used to seeing when you find perimeter. You want it to be a number. It's this expression. And then area for a triangle is 1/2 base times height. You also might see it as base times height over 2. That's fine. So here's the thing about base and height. They have to be at a 90-degree angle because height is going to be perpendicular, which is what this little symbol means, to the base. So again, I don't expect you to necessarily know that. I thought you learned it in middle school, but you never know. So let's call this the base, and this would be the, okay, because they're at a 90-degree angle. So we have that the area is equal to 1/2 base, which is 3mn squared, times the height, which is 4m squared. Okay, so now when we go to do this, we can only, again, multiply things that are the same. So we start with the numbers. We have 1/2 times 3 times 4. And again, if you don't have a calculator, you can use what is, other calculators or using Google. So I'm going to do 4y equals, there's my fraction. So 1/2 and then times 3 times 4. And that gives me 6. Okay? So I have 6 for my number. Then I have m here, and remember that's the first, and then m squared. Now when we combine those, we add the exponents because there's one m here and 2 here. So that's m cubed. Then my n squared is just a little solo. There's no other n's, so you just leave them alone. Don't change them. N squared. And there you go. There's your area and your perimeter for your triangle. So now here, it's another triangle, but it tells me to assume that it's an equilateral. So again, the perimeter is the same. You can actually look up an equilateral perimeter if you want to, but we're going to get to the same answer, so it doesn't super matter. The thing you need to know about an equilateral triangle is that equilateral means all the sides are of equal length. So if this full length here is 8mn, and that means this one is 8mn, and this one is 8mn. And again, it doesn't matter what we name A, B, and C, so I'm just going to do this one as A, B, and C, and we'll add them up. So P is equal to A, which is 8mn, plus B, which is 8mn, plus, and then C is 8mn. Okay? Hopefully you know, because it's the same thing 3 times, they better be like terms, because this, and this is going to be the same every time. Mn, mn, mn. What we do is we take the numbers 8 plus 8 plus 8, and hopefully you know that gets you 24. And then again, remember the m and part is exactly the same. Don't change that because that's the part that the terms are the same. So if it's the same for these, it better be same for the answer. Okay. And then we're gonna do the area. Again, doesn't change. So again, I kind of cheated and made this one B because this is indeed the base. The base is like the bottom. And then notice here, that's my perpendicular sign again. So this is H. And notice I have an arrow pointing to it. The length of H, or the height, is 4m squared. So just remember that base and height have to be perpendicular. So the height of the triangle is actually this, not that. This is how tall it is. This is if I was to walk up the side of it. So I have A is equal to 1/2. The base is 8mn. So 8mn. And then the height is 4m squared. So again, I'm going to only multiply the things that I'm allowed to. So we'll start with the numbers. Again, we have 1/2 times 8 times 4. So 1/2 times 8 times 4. I got lucky. There was a lot of repeat numbers there, and that answer is, boop, 16. So 16. And then again, I have m here, which is the first. Okay, it's not written there, so you can write it in, and then m squared. So again, when you multiply those, you simply add, because you have m and then 2m here, so m cubed. And then lastly, we have n, it's just one n all by itself. Okay, so there's the three problems that ask for perimeter and area. In this next section, it only asks for area, which is pretty good for us because they're a little bit more complicated. But here's where we're going to be applying a little bit more than what we learned before. So here, first of all, this is called a trapezoid. And the area, because remember, please read your directions. It's only asking for area. The area of a trapezoid is kind of like a triangle, but a little different. It's 1/2 base 1, so b sub 1 plus base 2, which is b sub 2, height. So those are in parentheses, those are together. So the bases are a top base, which I'll call b sub 1, and a bottom base here, which I'll call b sub 2. Some people might call them different things. People sometimes call them big B and little b, but remember, when you do a sub script like this, it's down below. It's not an actual operation. It's just denoting that they're both bases, but they're two different bases, one of them and two of them, okay? So those are our bases. They are parallel to each other. All right, so now we also want our height. Our height, remember, it has to be perpendicular to the base, and it actually is perpendicular to both of those. Not super important right now, but that's my height. Okay, great. So now I know the area is 1/2, parentheses, base 1. Base 1 is 7a squared b plus base 2 is this one down here, 11a squared b, and then times the height, which is 3ab. Okay, so now you have to do order of operations. So the first thing in order of operations is parentheses, right? So if there's anything to do inside the parentheses, we got to do that first. So inside these parentheses, we're adding 7a squared b, 11a squared b. Well, notice 11 and 7, a squared b, a squared b. They have the same variables to the exact same exponents. So that means that I can actually add these together. So they're going to be a squared b because that part doesn't change. But 7 plus 11 is 18. Okay, so that's the only thing I've changed. Everything else is just going to come down around it. Equals 1/2 times this times 3ab. I didn't change anything else, I just brought it down. And now, if anything is raised to a power, if a number was raised to a power, I do it. A squared, I can't actually raise that to a power. So we don't actually do that one because I don't know what a is. It's an unknown. Then we're on multiply, and that's actually the last thing we have. So when we multiply, we again have to do what we've been doing, which is multiply the numbers. So we have 1/2 times 18 times 3. So A equals, and I'm just going to tell you right now that that's 27. And the reason it's 27 is because half of 18 is 9. 9 times 3 is 27. So that's how I got it. Again, use a calculator is totally fine. Then I'm going to combine my a's. So I have a squared, and this one must be a to the first. Well, I add those. So a squared, a to the first, 2 plus 1 is 3, a cubed. And then lastly, I have b to the first and b to the first again. So again, when you do b times b, now I have b squared because 1 plus 1 is 2. So my final answer is that the area is 27a cubed b squared. Again, I know, weird answer, but that's what it is because all this is doing is the application is you need to know what the formula is, and then you plug the stuff in, and then you use what we've learned. When can you add things? When can you multiply things? So then the last one, which is probably the trickiest one because it's a circle, and the area formula for a circle is area equals pi, which is an irrational number that it just keeps recurring, and there's no fraction form, so we use the symbol. It's technically a number, but you'll see we just kind of tag it around. R squared, and only the R is squared. I don't know why I put that in parentheses. I normally don't. I think I was probably about to put that in. So radius, and the radius is 1/2 of all the way across, right? It's from the center out. So if I plug this in, remember pi is not an actual variable, it's a number, so don't replace that with anything. R is 3x cubed y squared. Nope, sorry, no y, no squared. And then this squared goes on the outside. So it's really important to put that on the outside because it applies to all of R. And this is all of R. And if you remember from the notes from today, the way this works is everything in here is going to be, this power is going to be applied to it. So we're going to have the 3 squared, the x cubed squared, and the y squared. Okay, so that means we have pi, and then 3 squared is 9. So that's what it means when it says in PEMDAS to do an exponent. I can actually do that exponent. I don't actually know what x cubed is. But when you have an exponent to an exponent, you are supposed to multiply those. So we get x to the 6th. And remember, that's because you end up getting x cubed times x cubed, and then you would add those, and 3 plus 3 is 6. So that's why you end up with that. And then here, there's a 1, and when you multiply 1 and 2, you just get 2. So you get y squared. And then there's just one last thing I have to change, is that technically the number is supposed to come first, and then pi can come because it's a number, but it's not a nice number. So you get 9 pi, and then these in alphabetical order, x to the 6th, y squared. And there you have it. So this one actually applies the powers to a power, because you have that 3 squared, x cubed, and then that squared. Okay? So the main thing here is know the formulas. You can look them up online, obviously, and then plug in what you know to be the certain parts of the shape. So the radius, the bases, the side lengths, the length, the width, etc. Plug them in and then compute them using the rules that you've learned over the past couple days. All right, I hope this video is helpful, and good luck.